Hello there. Today we are going to cover 9.2 translations. You guys will be able to draw these and describe translations. Our first vocab term, and only new one today, is translation vector. And this is probably the first time you've actually seen that term vector. So we're going to jump right in. A translation is a function that maps each point to its image along a vector, called the translation vector, such that each segment joining a point in its image has the same length as the vector. And this segment is also parallel to the vector. If you notice here, these guys are parallel and congruent. To denote a vector, it has a sort of fish hook type look with the letter of the line underneath it. So that is a vector K. Just telling us direction of the way it goes. The arrow also means something. That is a directional arrow that way. So point A moves to point A prime along that vector. So we can look at this being parallel and congruent. Nifty here on our notability, because we can just take it and pull it over and see that it is the same slope as well as the same length. They're parallel. Okay? So if we come down here and we have to use the given translation vector to draw the translation of the figure along it, we can go ahead and trace this guy. It's getting easy here on our notability. We have vector W, and then we can just bring this up. We know that H is going to become H prime down here, and so on and so forth. I will become I prime. J will become J prime. And G will become G prime. So we used our vector, that same slope, the direction, the same length, to figure out where H prime, I prime, J prime, and G prime will be. That last one's not so good. Here we go. All right. Okay? Now a little side note here. First of all, make sure that you're still labeling your original as well as your new points. Those are your pre-image and your image points. And also, vectors in real life are used a lot. Pretend this is the state of Indiana. I'm not a super great drawer. But think about watching TV and looking at the weather. A lot of times, they'll have something that looks kind of like this. The blue usually stands for cold air. The red will stand for warm air. They have a vector diagram which shows us the way the winds are coming in. Sometimes they meet up. It is showing us where it is moving from and to, something like that, right? Or you can also sometimes see like the west coast of the US, and they show like the water currents. Those are vectors. Okay? So those are real life examples of vectors and how things move. This next one, it isn't my favorite just because I don't actually think any of these answers are super great. Because if we do this tracing method and we go ahead and check from A to A prime, say, A to A prime actually isn't technically very good on A. On B, it's even further away. On question C, it's definitely in the wrong direction. And D, it is also very far away. So A is the closest answer, and if we weren't actually checking with this line, it would probably be the one that I would choose. But it's not super exact. But the other ones are definitely incorrect because the vector would have to go straight over, or up to the right, or really far down to the right. So A is our best choice if we had to choose one. All right. So all of those up there, they were kind of arbitrary. We had to figure them out just by using the lines and tracing and all that sort of stuff. In the coordinate plane, it's actually easier to translate a point along vector A, B, add A to the x coordinate and B to the y coordinate. Now here, if you ever need to write a vector, which you will, vectors are written in something that I like to call pointy brackets or pointy parentheses. This is standing for a vector. All vectors need to have that notation. And this I will call function, or it is called function notation. So when you're asked for function notation, you will write this thing here and plug in your vector to A and B, okay? So notice, this just tells you how your pre-image moves to your image. You simply add your vector to it. So let's try one. We need to graph triangle TUV. Alright, there's triangle TUV, and then it is along this vector. So I usually rewrite TU and V and then I write T prime, U prime, and V prime. And then I take these guys and I write them into my parentheses, but then I add or keep the sign technically of the vector to it. This will give me my T prime, U prime, and V prime. Notice these are still normal coordinates, so they don't have the pointy brackets. They're just plain old coordinates. And then I solve. Now I'm going to go ahead and show you where each thing goes. That way you can kind of visualize it, hopefully. And then I'm going to solve these out. So we have T prime is -4, -2. U prime is 3, 4. And V prime is 2, -3. Make sure this is good notation here. Don't slack off on your notation as you work through it. And when you graph these points, don't slack off on your graphing. So this is T prime. And then connect your points. And that is our new image based on our pre-image. Now there is a sort of shortcut we can take. You know that the vector is telling us what direction things move. So if you start at say T and you count over 3 to the left and then up 2, you will get to that new T prime. Same thing with V. If you count over 3 and then up 2, you get to the new V prime, and over 3 and up 2, you get to that new U prime. So you can use that sort of shortcut if you would like. I'm totally okay with that. Just know that you might have to then still write these coordinates as part of your answer. Okay, we're going to do it again. You can just follow along. Graph my pentagon. There we go. And then I go ahead and I need to translate it along this vector. So I'll show out one example of how I would write it out if I was going to show all my work. and then show you how I would do it if I wasn't going to show all of that work. So P prime, oops, don't forget the prime, is -4, -1. Now if I wanted to just count, I would go 1, 2, 3, 4. Oopsie, I did not graph that correctly. There we go. 5 down 1. Good thing I had to check it. Okay? So, if you are using this guy, you always go from the origin. If you use this guy, you go from the point that you are trying to find the prime of. So, E prime will be here. Now I'm just going to count from here. N prime, T prime, A prime, and then draw in my new image. Okay? That is the translation. Notice the translation never changes shape or size. It just moves around as is on the graph, okay? Now these next two, we are not given a graph. We are just asked to find the new coordinates of A prime, B prime, C prime, given our vector. So we can do that longhand sort of. I'm actually not going to do the whole thing. I'm just going to go ahead and say, okay, A prime is -3 minus 1. -2 plus 3. B prime is 4 minus 1, 4 plus 3. And C prime is 3 minus 1, and -3 plus 3. And then I go ahead and solve for A prime, B prime, and C prime. And there is my solution. Notice I labeled them correctly. I want that whole thing when you're writing out these. All right, now we do the same thing, but this time we have 4 points. Once again, now the vector is 2, -2. So that is repeated in each of these. Okay, so if you notice the vector is in each of these, that's good. And then the rest of the parts in them are just the coordinates that we were given. Do your best, don't make up signs or anything like that, or else you won't get the right prime points. And there you have it. There are your new image points. Okay, the last thing we have, instead of being given our vector or our function notation, we are going to try to find it given a graph. So use this translation. I do want to point out, write the translation of the range out from position 2 to position 3. So we're starting here, we're moving to 3. You have to write your vector based on that. If you go from 3 to 2, you will definitely get it wrong. Now I know the vector is the second thing they ask us to find, but I like finding that first because I can say, okay, from 2 I count over 1, 2. That is -2 since I went to the left, and then I went 1, 2, 3 down, so -3. That makes it much easier to find my function notation, because when using function notation, we always have x comma y, 2x, and then plug in your vector, -2, y -3. All right, from here, you can say, using words, from position 2, move left 2 and down 3 to position 3. All right? So you just have to figure out where you're going from and then where that is going to, and then write your vector and fill everything in. Same thing here. Once again, we're from position 2 to position 3. So we're going to go over 1, 2, 3, and then down 1, 2 for our vector. That means we can fill in our function notation. It looks like this every time. The only thing that changes is that vector that you place in there. And then using words, we can use the same basic thing. But change which direction and how many spaces. And then we're done. Alrighty. Have a great day.